afternoon. I think we can start. As you have heard, my name is Michal Ružička. I'm from Masaryk University, from the Institute of Computer Science. And as our university is very active in open science activities and implementation of EOSC in the Czech Republic, I'm also active in National Repository Platform project and other relevant stuff. I will talk in a few minutes, and yeah, that's more or less what we will be talking in this session. My presentation is named Introduction to FAIR Data. And in fact, when I was preparing it, I was not completely sure what's the target audience. So let's start with a small voting, maybe. Who of you know what's FAIR data? What's okay? So it seems we really can start from the beginning, and with the full context of what we call open science and other things. Then I will start with my favorite schema of research data lifecycle that somehow corresponds with life cycle of research projects. Then we will look at the data, what are managed data, what are open data, FAIR data, and how it works together. Then we will see how it can be relevant to you, as I expect you are project investigators, maybe main investigators of projects, or maybe PhD students that are working on some research projects. And as you will see, some requirements on handling data and open science principles are, as of now, common requirement of grant agencies. Then we will go to a bit more practical things. At the example of our institution, Masaryk University, I will show you what we are providing to our researchers as some categorization of available data storages and where to store data in different phases of their life cycle. And then we will continue with some more tools and resources that can be useful for you. We will also spend a few minutes with persistent identifiers, as we will see it's something that's very useful and necessary for FAIR data support. And we will end up with repositories, that means storages or storage platforms for final results that should be shared and preserved in the original form with no modifications, unintended modifications. And it's closely related to the EOSC activities here in the Czech Republic and so-called National Repository Platform that I was telling you at the very beginning I'm also working at. So that's our plan. We have something like 2 hours. I hope we will manage it a bit quicker. And please, if you have any question, don't hesitate. Just wave to me and ask anytime during my talk. I think it's much better than waiting at the end when we will lose the context. So let's start with the context. I have here a very simple schema with a lot of open things, like open access. Who of you have any heard about open access? Yeah, I expect it. That's probably the most classical or the most used, maybe not the most used, but definitely the most known part of this, and it's about publications. And as of now, you probably know that having a PDF of an article from a good journal that has something like 10 or maybe 20 pages, that's probably not enough space to provide you all the information about a few years of the research and all the experiments at gigabytes, maybe terabytes, or maybe even more data. And that's just a very, very concentrated summary, but definitely a lot of context is missing. So that's the reason why we are now focusing on data. On this schema, to have it open in it, we have open data, but in fact, open data is a very small part, and we will more focus today on fair data or maybe managed data. That means data, we know what's the origin of them, how to interpret them, and so data that can be really used as we know enough about them to use them and don't misinterpret them. I also expect you have heard about open source. That's extremely important part, and I think the part that is not as of now as highlighted as it should be. As with piles of data, gigabytes and terabytes of data, none of you is, or almost none of you expect from some mathematicians maybe, is processing data with just pencil and paper. So we need computers, and we need computers with software that's able to understand the data, process them, and in fact, in the publication, we probably have some graph that's just analysis and some processing of the data. So software and full pipeline of the processing with proper track record of the provenance of processing the data is also very important. And other open things in this schema are helping us with it. For example, open notebooks are now trend for laboratories, how to keep track of processing of physical samples and other things we are doing in the laboratories. Open peer review is somehow connected with open access. With review process and publishing process of scientific publications. There are social networks, open educational resources, and maybe citizen science. Do you know what citizen science, at least at the context? Yeah, that's a principle when we are trying to somehow get non-scientists, but amateurs in the good meaning, amateurs that are enthusiastic in something, and sometimes they are at the same level as experts, but just working for money in a different area. But as they are enthusiasts in their area, they know. For example, I know that ornithologists, they are doing from time to time something like counting birds and different species of birds and at the different parts of our country, and they are asking regular people that are interested in environment and birds to give them information what birds were observed at what location at a particular time. So they are making common people some sensors that help them to observe and get information from different parts of the country, maybe at the same time. And yeah, that's not completely trusted source, but they are they are trying to use it somehow, and that's just a small example. Why this can be interesting for you? In some project calls, you can get bonus points for following citizen science principles in your project application. That's not a mandatory principle, but if you are using it somehow, you can get some bonus points in the evaluation of your proposal. So that's the context. And now let's to see what happens in the life cycle of the research data. It's a circle, so it's hard to say where is the beginning and where is the end, but I think it's a good idea to start with planning phase. It's obvious that if you are planning some project in formal or informal way, you are thinking what you are going to do, what you will need, what are some risks, where you will get experts and staff to do it, what instruments you will need, what software, etc. you will need. And that's something what's relevant for data and research projects, as data are so important part of the research project now that grant agencies sometimes almost always now need something called data management plan, where you will describe how you will handle data during the full project life cycle. So be prepared that this planning phase you will have to materialize as a document or something more than a few notes on working with data in the main part of the project proposal, maybe. Then you will collect data, and that means not only you are generating completely new data on your own, but it's often reuse of something existing. And that may be data set from your own previous research, or data set from some colleagues, or maybe data set that is published is something like Meteo Service, National Meteo Service, or maybe some traffic information from some public agency or something like that. Then you have to process and analyze the data, and in this step you should collect and save proper metadata, what you are doing, keep the tracking of provenance of the information. Of course, during the analysis, you need some storage where the data are kept, and you will need also some long-term storage for preserving the data, as usually when the grant agency will pay for you for getting the data, they will also keep, not to delete them after the end of the project, but to preserve it to be reused by someone else. That's one good reason why to preserve and share the data. And another very important, and maybe for me personally, maybe even the more important reason, is to verify or be able to verify the results. Who of you have heard about reproducibility crisis? Yeah, some of you. You know that even in very good journals, it happens from time to time that some articles are retracted, as it happens that no one is really able to reproduce the results, and sometimes it's due to some mistakes, sometimes it's even bad behavior of the original authors, and publishing and keeping data to be able to verify the results is very important. And be aware that that's the problem across all the scientific areas, and maybe in areas like pharmacy, it's a real problem, as it happens that some medical preparates are maybe not as good for your health as was expected, and sometimes they may be even harmful. So that's why sharing and preserving and reuse is important. So that's another view of the context and what we are, why we are doing it. Now, what are data, managed data, fair data, and other things I was speaking from the beginning. If we see the biggest circle as all data we have, just a subset, and that's of course the question how large subset of the all data can be marked as managed data. As managed data, I mean that someone knows where the data are stored, what's the origin of the data, how they were created, measured, or something like this. It has the author is known, and what's the most important, the proper interpretation is known. So you are able to reuse the data somehow. And if you will reuse it, you can be more or less sure the interpretation, the information, the knowledge you are getting from the data is correct, as you know enough about the data. Yeah. If you will find some random flash disk with some binary file, you are probably unable to use it. You simply don't know how to use the data. If it will be some CSV file with some numbers in rows and columns, you are unable to use it. You simply don't know what the numbers mean. If you have proper description in some README or some XML metadata file in a common format with regular and known meaning of every term or item used, then you can use the data as you know enough. Even smaller subset of managed data are so-called FAIR data. The FAIR is acronym of some English words: findable, accessible, interoperable, and reusable, and that simply provides some very generic, very high-level guidance what should be done to make the data as useful as possible. You will see more on it in next 2 more slides. And the last circle in this image is called open data. As you can see, it's going across many categories, and that's specific category of data that are publicly available. They are accessible from web, on unauthenticated website, so everyone can get it. Yeah, that's very specific category of data. And very important thing is that data in open science definitely are not required to be open. What we, in fact, are targeting on open science are FAIR data, if possible, but managed data is the category we are targeting. If you have sensitive data from medicine with personal information, no one will force you to publish it anywhere. Yeah, you can, and you are required, in fact, to safeguard the access to such a data. And if you have some very nice idea and you are getting to get a patent, again, no one will force you to publish it before you will get the patent. It's completely valid and still under the hood of open science. What we want from you is to properly manage your data, to know where you have the data, how to interpret them, how to use it. And if someone eligible is asking, you will be able to answer with the data or with some analysis based on this data with the knowledge how to analyze them and interpret them. Okay, now more on the usefulness of the data. Maybe here we have open data, but the same is valid for managed data or fair data. Yeah, this is valid also for your own data set that's on your private storage and not shared with everyone. It's based on a so-called five-star linked open data by Tim Berners-Lee, and the basic level of openness or usefulness of data is if you have PDF. That's the very basic level. In fact, that's just one step above having just a paper with printed text. Yeah, it's more or less unprocessable by machines. Yeah, you have just electronic text, but very often with no structure marking. Yeah, it's just plain text, maybe with some tables and images scattered across the page. So yeah, it can be processed in a computer, but that's more or less all. So what we want more it to be processed by machines. Some Microsoft Excel file, and preferably the old one, the binary, not the XML version XLSX, but the original XLS file is some example of it. Now you have a table with rows and columns, so it's somehow structured, but it's still very suboptimal, as it's intended for humans to have some colors in it and maybe some merged cells with some nodes, and it's still suboptimal as the pure data is often combined with some human readable, some markups for humans, some colors and things that are intended to be read and interpreted by human. And if you are a programmer, or if you have ever tried to process some Excel file, you know it's pain. What you want, if you are going to process it by machines, is, for example, CSV file. That's plain text file with structure, and it's impossible to have here some strange things like color markups and other things. So it's easily processable by machines. In Linux shell with some very basic Unix tools, it's easy to process, but still with no additional information, you don't know what the data mean. Yeah, you have just a table with some numbers or maybe text in the columns and rows, but you don't know whether it's table of names and ages of us here in this room, or maybe names of the streets and number of cars at the street that are usually parked during the day at that street. Yeah, you don't have enough information. So you in the upper levels of open data, you have formats that provide you some standard notation. For example, it's some machine actionable file format like XML, JSON, CSV, and some description of the particular used format. For example, for XML, it can be XML schema with the description what texts are available at what levels, what that means, how to interpret the value in this stack. And if you are using RDF, for example, you can also mark the relations between different documents. So that's what we are now speaking with managed data. For current needs, we need machine actionable formats, as we have a lot of data, and we definitely need to process them in batches, large batches, automatically by machines. And to be able to interpret them, know what they means, we need to use standard formats with known interpretation of the data, or if we are providing our own data set, so we need to provide enough description to give others enough information how to interpret the data. Yeah. So yeah, is it clear as of now, so far? Yeah. Okay, that's about the data itself. And as I told you before, this is it's also important to have software that's able to work with the data we are publishing. Okay, now back to FAIR principles. Yep. Maybe please wait for a microphone, as we are getting recording of it, so to be.
If I have a CSV file with a header at the beginning with a comment of what are the fields,
yeah.
Is this 4 stars in the rating?
Yeah, it's a very good question. I think it's better than a regular CSV, but not as good as XML file in some known format. For example, XHTML, that's standard. And for example, your web browser knows that when the tag title is found in the document, then it should be the text that should be displayed in the header of the tab in your web browser. If it hit H1 header, H1 tag in the document, yes, your web browser knows it's level 1 heading of the document and should be displayed in bigger text and maybe bold at the proper yeah, probably at the beginning of the web page. Yeah, that's what I meant when using some open standards, commonly used data formats, when more or less everyone knows how to interpret the data. Yeah, if you will provide some comments in the heading, if it's your own data table, yeah, probably it's good. Someone who is going to reuse will at the beginning have to see what are headers and probably configure or program his or her own processing pipeline to know. But then if the format is stable and used across the data set, at the initial, after the initial configuration of the processing, all the data can be processed and it will work. Yeah. Okay. What are the FAIR principles? As I told you, these are more or less some high-level hints how to handle your data. The first thing, findability. Make your files, your data sets findable. What it means in practice, The first thing is to use machine processable metadata and data to be able to index it. Yeah, to make it findable, for example, by Google, you need to put your data somewhere where Google is going to see. That means more or less the public internet, or to some repository that's intentionally providing to the public internet, to the Google bot, some metadata about the contents. And yes, it can be findable. And it's also very useful to assign some persistent identifier to the data. Who knows what's a persistent identifier? Maybe. And who knows what's DOI? So you know what's persistent identifier. DOI is one example of persistent identifier. That's unique ID, usually alphanumeric ID that can be used to using some service, some DOI resolver. In case of a DOI, that can be used to get the identified objects. And it's also unique globally. So if you somewhere provide DOI, everyone knows the particular object, and there should be no collisions between different objects. So findability is one property. The second property is accessibility. That's more or less that the data are available with commonly used technologies. Currently, for example, HTTPS protocol that's used by current common web browsers. It's an example of this technology. Yeah, use HTTPS or maybe S3 protocol for big data sets, and that's more or less it. As I told you that fair data definitely does not mean open data. It's perfectly okay if some authentication and authorization infrastructure is used. So if you are going to see who is going to use or access the data, and just selected users allowed to download them. Again, use common protocols and technologies, for example, OpenID. That means something like sign in with Google, or single sign-on at your institutions that they are usually using so-called OpenID Connect protocol, or maybe XAML protocol. That are common protocols that are used for it. And again, use metadata, or metadata should be again accessible in the same way. Interoperability is something very, very similar to the accessibility, but not about the protocols, accessing protocols, but about the data itself. That's more or less this. Yeah, use machine actionable, machine readable, common standardized formats, like XHTML, for example, and preferably the formats with more stars. Yeah, the CSV or some XML, JSON is better than Word or Excel or similar files. And the last principle, reuse. That's maybe not the principle, but the reason why we are doing it. Make the data in a shape to be reused, for reuse by someone else, or for verification of your results. And make it, to be reusable, one important thing is clear declaration of license. It's very important. If you will publish anything without explicit license, then you have not published it at all, as no one is able to reuse it or no one with some lawyer at the institution he is working for, as the institution will naturally not allow him to use it, as the lawyer will telling him it's too dangerous for the institution, as someone can come later and want something as they not used, they misused the data, for example. So it's very important to declare license. It's if you are openly sharing your work, it may be and it's data, not the software, as software is using different licenses, but Creative Commons licenses like CC0 or CC BY are usually the good license for this kind of use. So that's it. Yeah, and again, metadata. You need metadata. So to be reusable, you need the metadata to allow interpretation of the data that are published. So another view on FAIR principles is so-called FIP profile, FAIR implementation profile. And what's this? More or less some particular technology or technique system that will be used to fulfill particular requirement of FAIR data. So, for example, if we have a requirement for persistent identifiers, okay, we can choose DOI, for example. And if you will fill answers for these 15 or something like that questions, you have probably solved your plan for fulfilling FAIR data requirement for your dataset, maybe. So it's not hard. In fact, I hope all of this you are doing for your research for years and years and years. What's now changing, we explicitly want to be aware of these properties and when possible, publish and share the data using the infrastructures that are available. So now we are slowly going to the data management plan. As I told you at the beginning that this thing, the planning, is now commonly required by grant agencies, and they simply more or less, if I make it very simplistic, they want something like this. Tell them what's your plan for fulfilling data sharing requirements and good management of the data. I have in a few slides some few examples from Czech environment, Czech project calls that are relevant here in the Czech Republic. The first one is Horizon Europe, and you will see it's more or less, the requirements are more or less the same. DMP is mandatory as part of it, and Horizon Europe for years provided some template of the data management plan. It's not required form, but it's commonly used as an example how the data management plan can be seen. In fact, the grant agencies usually want a document, but for data management plan preparation, specific software for purpose software can be used. One example is Data Storage Wizard, and you will see later it's one component of the National Repository Platform. So support for creation of data management plans, and the planning is one part of the NRP, National Repository Platform. Gutcher have a similar requirement for it. DMP is required. It should be submitted with interim reports and with final report. One important observation is that DMP should be living document. It's completely valid that at the beginning of the project or when you are preparing the application for the project, you have some plan, but after 2 years, you have different software, maybe you changed some instrument, maybe some stuff, and it's completely valid that the plans or practice of handling data has changed. And you should reflect it in the data management plan. So it's not only plan, but it should also be some summary of the practice, current practice in the project. So it's usual that the DMP updates are submitted regularly as part of some interim reports, for example. And also the requirements of on handling data from Horizon Europe, Gutcher, and other agencies is usually similar. They want to follow the principles of open science that can be concentrated in one sentence, as close as necessary, as open as possible. Yeah, when possible, share. If not, if it's not possible, for example, due to some personal information or something like this, it's okay. But again, you should be managing properly your data, just not publishing them openly. Yeah. There are also projects from health research and others, again, very similar. DMP mandatory and follow the practice of publishing data when necessary. So what can be some example of data management plan and what should be described in the data management plan? I have some example here. By the way, this link is again PID, kind of persistent identifier. In this case, it's not DOI, but so-called handle. And in fact, DOI is technically at the background using handle system. But that's not important, but just to show you another example of PID. So at this URL, you can get this document that's some few years old data management plan for some Horizon Europe project. And I'm using it as an example, as it has several interesting properties. The first one, it's a project from social sciences. So not only researchers in a laboratory working with physical samples of blood or something like that need descriptions of handling data, but also social scientists. For example, they often work with people and asking them, having some interviews, and it happens they are getting audio and video recordings of the interviews. They usually have some transcriptions of the interviews, and it often are on some sensitive topics of work, life of the people. So it's usually also sensitive data that are involved in the recordings and transcriptions of the interviews. So you have restricted access to the data, and it's described in the document. They are combining existing data from, I think, some state agencies, some statistical data, and they are also collecting their own data. It can be seen in the document. There is it's not in the outline, but there is version history of the document with a short summary what has changed in different revisions. So it's continuously updating. For example, there was described migration of data to the UK after Brexit, for example, and encryption of data in cloud storage, as they are describing the safeguarding measurements to protect the sensitive data. Ethic aspect is described, referencing the ethical commission resolution. So it's perfectly okay in your data management plan to reference some sources with more details on some topic. It's also joint project of multiple institutions, and nice thing in the data management plan is that responsibilities of different institutions is described here, and also there is a description of intellectual properties that can be useful if the results are good, and for example some commercialization or patent or something can be produced after the project, having a clear declaration of what part of the project and so what part of money is getting to what institution it can be useful. Yeah, description of data protection. Even publications are part of the data management plan, as publication is also kind of data. Yeah? If you have PDF of the publication, it's also kind of data set. And what I really like is the description of quality assurance process. In the data management plan, there is description who in the project is responsible for final marking. Okay, this data set is in good shape and we can publish it with the logo of the project. We are sure the data are in the good quality, and also description of internal processes in the project are described. So to be sure that the data are really managed, yeah, that not in this case of social scientists are, for example, some standard operational procedures in the laboratory, how the instrument is calibrated, for example, its quality assurance process, and it should be described here, or relevant documents, for example, the soaps in the laboratory should be referenced. And all in all, you are providing some formal description for the project grant, for the grant agency, that you are getting serious and in managing your data, and you have good plan how to do it. Okay, do you have any questions? Was this clear so far? Now we are going to some more practical examples. If we have some plan, so we are going to really do something, and so we need, for example, some place where to store the data. This will be example from my institution, from the Maastricht University. As I told you, I'm from Institute of Computer Science, and that's service center, research center at our university that's, among other things, taking care for some storage infrastructure at our university. And we also have publicly available catalog, it.muni.cz, where we have catalog of IT services for our staff and students and researchers. And one thing in this catalog is some recommendation on available storage technologies and how to use them. In fact, there are two main parts. The first one is a set of storage technologies that are available, and we are starting at flash drives and external hard drives, maybe CD, DVD, and something like that. So storages that you can have in your pocket, for example. Then we are describing storages in your computer, in your bag, your notebook, or workstation in your office. We also have some network storages, the central storage servers. We also have a reference for storages provided at the national level. You probably know CESNET is providing not only networks, but also some computation and storage infrastructure. And as academic institution, you can use it. And we are also using some services like Microsoft Cloud services for document storage. We also have kind of Google and services like Grammarly, etc. And what's very important, for example, Google OneDrive or Microsoft OneDrive or Google Drive is something that can be used from the Maastricht University tenant with all proper agreements on data protection and what can or not can be done by the service provider, by Microsoft or Google with the data. And it's okay for use for work data and research data. But I expect all of us have some personal Google account, for example, with associated storage services. And the thing is, for the end users, it seems to be very the same thing. It's the same app, it has similar design, but the data that are stored to my personal Google account can be more or less used by Google for anything. And it's more or less Google data when I store it on the Google account, my personal Google account. And it's completely different thing for if you are going to use it for your research data, your work data. And it's very important to educate the users. It's different kind of service with completely different service agreement. And as of it, it's more or less completely inappropriate for any data that belongs to our institution, for example. So the type of storages, that's one dimension of this matrix. The other dimension is some classification of data. We are using for this recommendation, we are using 4 categories. The first one is public data. That means, for example, this presentation, it's public. I don't mind if anyone will see it, and also my institution will not mind. That's probably even more important. But there are also some internal data. For example, notes from our internal meetings at our institution, our department, or our lab. And these are not meant to be publicly available. On the other hand, no top secret information is inside. So if it will leak, we will not be happy, but it will not be a catastrophe. And at the other side, we have sensitive data, really sensitive data. For example, information about patients from Faculty of Medicine, for example, and these have to be really safeguarded, and we have to take care no one will get access if it's someone from the short list of valid users. One important thing when we are speaking about protection of data, usually everyone is scared of hackers, so we won't protect our data to leak to someone who should not get access to it. But we also have two other things. For me, it's also important to me not to lose the data. So if I store it to some storage that malfunction, there is some mechanical problem with hard drive, for example, or some I don't know, flood in the data center, and the hardware is damaged. I want the storage system to be backup, for example, or provide other things to protect the data from me to losing them. Yeah, that's second important thing. We are protecting our data, and the third one is we want to keep integrity of our data. That means be sure that no one will change the data without intention, and yeah, we don't want to modify the data with our intention and knowing about it. And that means not only, for example, humans changing the data, but again, the storage system have to be designed so that some technical errors of degradation of media or some error of one hard drive in a storage system should be detected and corrected from a spare copy of the data. So me, as the end user, will always get the data that are wrote to the storage system. Yeah. So I want to get the data, get the data I stored to the storage system, and want to protect the data to leak to anyone who is not authorized to get them. And more or less, that's the filling of this two-dimensional metrics. The recommendation itself, what data storage is good or not good for what class of the data. And this is a very high-level view. Part of the recommendation is also more longer document with more details why this recommendation for this particular data and this storage type is done. Okay, that was one example, and I think it can be more or less applied also to your institution, as I think you have more or less the similar categories of data and storage systems. Okay. Other tools for supporting FAIR principles. I really like so-called RDM kit. That's a result of Elixir project, and that's web with some links on different tasks. For example, you can do with data, for example, analysis or organization or storage. And at these sub-pages, you can get some useful recommendations and links to tools that can be useful to fulfill these tasks. So that's another kind of catalog or guiding document. That's one example. Another example, who of you know Jupyter Notebook or Jupyter Lab? Have you ever seen it? Okay, thank you. I recommend to you to see this URL. Some demo in your browser can be used in Jupyter Lab or Jupyter Notebook is some clever IT system that can be used to combine documentation and code. Originally, it was created for Python, for programming language Python. That's the reason why it's Jupyter with Y. But as of now, it's also available for C and Java and Ruby and a lot of other languages. And the thing is that you, as a user, uses your web browser, and it can be seen as kind of a Google document, for example. So you can write your notes in Markdown, and it is rendered as a text. And as you can see, you also use some math in LaTeX notation. So if you are describing some scientific thing with math, it's easily usable. And again, it's rendered using MathML. But you can also insert code blocks, for example, in Python. And the magic is that at the background, there is something running on the server that's able to interpret the code, for example, in Python. So you can run the code, and the result of the running the code, for example, some graph that's result of analyzing some data by the code, is shown inside the document. And it's interactive. So if you changed your code, changing the analysis, just hit the enter, wait a few seconds or maybe a few hours, depending on how long the analysis will take, and the result is shown. And the good thing is that you can download this document. In fact, it's just a JSON file, and share it with someone else. And someone else can it open in Jupyter. And by the way, even Google is providing on platform collab.research.google.com or something like this. More or less, if you upload this file to the Google Drive, you can open it and see the results. So you will see the description, the code, and the graph, for example, or table that's the result of the processing, and trace it as a paper. But if you have it open in the notebook, you can hit enter and change the code, hit enter again, and get the result for the changed code. So it's very, very, very nice way how to have good documentation of the code, how to sharing also the code you really have used, and if you will provide not only the Jupyter Notebook, but also the data that are used with the Jupyter Notebook, you more or less are sharing full provenance for information of your processing, and anyone is able to reproduce the results on his own computer. So he is trusting. He knows there is no malicious hack misinterpreting the data, and can see whether the processing on the data is providing the results you are telling it results. And very easily can start another reuse of the data with modifying the code, providing more data for the same code, etc. Yeah, so it's a very nice example, and I think it's now a very famous system and used. Another example of tool supporting fair data is a tool called Datalet. It's a tool combining Git, GitNX for handling large data that Git itself is not able to handle. By the way, what's Git? Do you know Git? The version control tool, originally developed for version control of source code, in particular Linux kernel source code, but now it's probably the most used version control system as of now, and GitHub and GitLab, all these tools are using it. So Datalet is a Python tool that's using Git and GitNX. That's extension for Git that allows you to version control large data, gigabytes, terabytes of data, and distribute them to different places and keep control over them. And Datalet is using this tool, these two tools, and provides you with some improved user interface and some additional layer that allows you to version control datasets, share datasets, support collaboration over datasets, and what's important, it also allows you to run processing of the data with keeping track of changes in the data and the invocation of commands, the processing itself. So you can see complete provenance history of a particular file, what's the original data, also keep track, for example, if you are downloading the data from the internet, Datalet provides you tools how to keep track of the original URL, the original source. Then you can do transformations and the version control similar to the Git. Then you can instruct Datalet run this command over this data, and he also keep tracks what command, what script was used on what data, and what was result of the running, and you can easily rerun the same command. So in the end, if you point to one file in the dataset, with one command, you can get complete history from the original file downloaded from some URL, then all the modifications that was done with complete track of what particular software with what parameters was used and what was the result of running. And it works very similar to Git, so it's easy to distribute, work in distributed environment. No central infrastructure is needed. It can be used if you prefer, but it's not necessary, and it supports a combination of text source code of software that's tracked with the Git itself, and use of external storages like S3 object storage from Amazon or from SysNet for storing the large data that can not be saved directly to the Git. And it's, I think, very nice example of handling data with also software, and what's important thing, keeping track of the provenance information. So if you share Datalet repository to someone, he can very easily see what particular processing resulted in the data you are showing to him. By the way, do you know Datalet? Have you ever seen her? Okay. And the last tool I have in this section is called OneData. It's a system for sharing data across different data centers, maybe across continents even. The intention is bit similar with data distribution, but by Datalet but with nice web user interface and clients, and focusing purely on distribution of data. It's not focusing on running analysis over data, but keeping track of data that are distributed across different data centers, and allows you to handle the situation when different centers across globe in different continents are producing a lot of data that are primarily stored at the same continent, more or less, near the data source, as distributing all the data across the globe will be expensive due to large amounts that should be transferred among continents. But one data allows you to see contents from all the data centers, and when needed, with few commands, few clicks, you can transfer the subset of the data you need in your data center to process it locally in your data center, and this information is then shared. So if someone else needs the same data, he can get the copy that's closer to him, or at the faster link, for example. So that's a data management system. Okay, so that were a few tools I consider useful, and now more on persistent identifiers. I think we have a few examples so far, but now let's see more. As we have seen, you are aware of at least the UI example, but I expect the UI is known to you primarily from publications, articles, yeah? Yeah. DOI, in fact, is quite universal and can be also used for identification of data set, but in fact, at least some agencies like DataCite allows you to assign DOI also to event or some physical object, like some statue in a museum, for example. So it's quite universal. The thing is, the data file or article are not only the objects I need to identify. You also need identifiers for persons, institutions, publication data sets, for example, some instruments, some physical samples in, for example, biobank, etc. So a lot of different examples. The main concept is that the identifier is identifying some object, and the identity of the object is different, or should not be mixed with the current physical location of the object itself. I will now use some example of a data set. It's a data set called HTTPS set. That was data set produced a few years ago by CERT-EMU, cybersecurity team of our university, and more or less it's a kind of record of network traffic at our university network, that can be used for experiments or testing some network analysis tools, for example. That's not most important, but thing is that when they produce it, it was large. Large means 200 gigabytes. So it was too big to be uploaded to Zenodo. And but they wanted to cite it in a paper they were publishing. So we decided to assign DOI to the dataset, and that's the DOI. Knowing that the current location is SharePoint of our university, and you can think that's not the best storage solution for some long-term storage. But we know that repositories in Czech Republic, like National Catch-all repository, will be built in a few months or years. I think years at the time of doing this. So that's no problem, as the current location, this large URL, is something that will never be shown to the user. In the article, this DOI was used, and everywhere where we can reference or want to reference the dataset, the DOI is used. And the service running at doi.org will point the user to the current location. As of now, I think it's still this URL, but if we upload the dataset to the proper repository, we then simply change metadata of the DOI at the data site. Nothing will change in the printed article. This ID is still valid. Just this service will point the users using this URL to the new location, and that's the important thing. This is identifier and service that will point you to the where you can get the object, and we as our institution, as owner of the ID, are responsible for updating metadata of this DOI to be sure that the user using this DOI will get to the proper object. So that's one example. Second example is on Pipe. As you can see, in the Czech Republic, a very common name is Jan Novák. And if you see somewhere Jan Novák or Novák, yeah, J. Novák, you probably don't know who particular person it is. This is a screenshot from author's base of DML-CZ project. So you can see one row is one physical person, and you can see what different forms of the name of the one physical person have been seen in different articles, as some articles are using accents, some are not using accents, sometimes the name is in the full form, sometimes just abbreviation is used, so it's a real mess. So you need some unique identifier. And for persons, ORCID ID is commonly used in research. By the way, do you have your ORCID? I have. Oh, perfect. And use it. If you are not using it, it's mess, and you are losing credit for publications you are producing, as mistakes are happen, and IT systems, as we have a lot of data, and it has to be processed by machines automatically. They need proper persistent and unique identifiers. Yeah. Another examples for other things, institutions can be identified by so-called ROR publications. DOI, we have seen it. By the way, DOI is system that has multiple so-called registration agencies. The most famous one is Crossref and DataCite, and both of them are assigning DOIs, yeah? The same type of identifier, different agencies that take care of the resolve service, metadata storage, interface for searching for metadata, etc., etc. Yeah. Yeah, handle another type of ID. If we are going back to the history or for some physical world examples, you probably know ISBN as identifier for books, ISSN for journals. You probably regularly see this kind of barcode on everywhere, on a bottle with soda and everything. That's some standard for European article number standard for identification of more or less anything in shops. And kind of rodné číslo in Czech, birth number, is also kind of ID. By the way, it's a good example what a good PID should not be like. Yeah, the first thing, it's not global. Rodné číslo is Czech standard. It's not more or less usable in other countries. The very bad thing is it has semantic. Yeah, from rodné číslo you can see whether it's man or woman, and you can see the birth date. That's something you really do not want for PIDs. For example, for articles, some journals have DOI constructed as abbreviation of the journal name, volume, year, and starting page, for example. The starting page and volume is not as bad, but in the DML-CZ, we have seen that during the years, the name of a journal is changing. Sometimes some mistakes happen. So, for example, some 2 volumes or even journals are merging together, and volumes have, for example, some changes in the numbering of the volumes, etc. So, if you have this in PIDs, always, more or less, in every case, it happens sooner or later that the semantic will break, and it is very inconvenient for the users, as something that was working to 2025 is not working anymore. And so please, if you are producing some kind of PID, make it random. Yeah, don't try to do any semantic in it. It will break and will make some mess later. Yeah, PID should be just ID with no semantic in it. I know it's sometimes useful for people, but yeah, use it just yeah, PID. So now time is approaching, and we are more or less going to the finish, as this is more or less the last part, where to store the final data, repositories. Repositories are the system where the final results, I mean final in that sense, that's something that should be kept with no more modifications. But it's of course possible you will publish later some new revisions with some other processing, but what was once published in the repository should be kept as a version with no more modifications, and new updates, for example, or new revisions should be published as another object with reference for the previous one, for example, but as a new object, and the old one should be kept for history tracking. What kind of repositories we have? For example, topical, national, institutional, catch-all. The preference is for topical. As if you have topical repository, your colleagues working on similar things will see all the relevant or probably relevant stuff at one place. Topical repositories can have specific, I don't know, view. If you are working in archaeology and you have 3D model of the physical objects that were found, the topical repositories, it can happen that we'll have some 3D view in the web interface that will allow you to see the preview of the object right in the web interface of this repository, as it knows the format used. It will also support the metadata format that's used in your discipline, etc. So topical repositories are preferred, but sometimes some national or institutional repositories are also built, and catch-all repositories are often used when you are not having the good topic repository or don't know where the topic repository is, and catch-all is trying to catch them all. Yeah, it should be usable all the time, every time, but with no specific support for particular formats or support for particular community. How to find? Maybe you know so-called referee data, referee.org webpage. That's a catalog of repositories with this is screenshot of some interactive search interface for a particular research area, and it's filtering the full catalog of all the repositories and filtering to the repositories that are valid for this research topic. Good repository can be, there are some standards for evaluation of trustworthiness of the repository, but for example, Zenodo has no certification, and it's very massively used repository operated by CERN, and almost everyone hopes it will simply work, as it's too big to fail, but has no formal certification. But some standards are available for it. So catalog of repositories can be used, and you should think of trustworthiness of the repository. Formal certification can be used, but that's not what's every time available. What you should look at when you are choosing your repository, is it able to provide you with the persistent ID? A lot of repositories, if you upload your data, your object to the repository, will provide you with PID. So you don't need specific support at your institution. Just with creation of the record, you will get PID that you can use. Trustworthiness is something you should look at. Access, whether it provides open access, or if you are handling kind of sensitive data, whether it's suitable, if it's suitable for a data type, and if provides you enough infrastructure for safeguarding access to your data is something you should think. Licenses is again something you have to keep in mind. Primarily, it's your responsibility to denote or attach license to your data set, but the repository should be able to support this agreement, and again the repository itself should provide you with kind of storage agreement, what are the what the repository will do or not do with your data. Yeah, that the terms of services more or less. Yeah, good repository should provide so-called landing page with elementary metadata that will be presented to the user, so he can get the basic information about the object prior downloading the object itself. And the good repository will also support versioning. Yeah, if you will find bug, mistake in the data set, or you will just update your data set, for example, getting even more data, you should be able to add new version, not replace the old one, but add new version of the data set. It's similar to the version control of source code of software, for example. So the last part, Open Science Cloud, European Open Science Cloud. As EOSC is something that's trying to support more or less all what we have been speaking so far. Support work with data, infrastructures for storing and processing data across the Europe. It's initiative that was started in Europe more or less 10 years ago, and key concept is data management and fair data. It's ecosystem of services. In fact, different countries across Europe have different activities in the context of EOSC. Here in the Czech Republic, we have, for example, a series of projects supported by Ministry of Education. EOSC CZ, CARDS, NRP, and other projects calls I will describe in more details in a few more slides later. It's also relevant for data management, and the main principle or objective is support for fair data sharing and reuse, and yeah, that's more or less it. To see the projects, different projects, the series of projects, this schema of EC can be used. In the center, I'm sorry, this pointer is not working optimally. In the center is a project called EOSC CZ, and that's the center in meaning it's trying to organize and coordinate other activities. It's supported by EU Secretariat, and there is also national metadata directory that should be some technical infrastructure, some repository aggregating metadata about data sets in the Czech Republic. And there is also a training center. By the way, this talk will be uploaded to the training center website and will be available here. The other project I mentioned a few times during my talk is a National Repository Platform. It's going to build foundation, technical foundation, meaning hardware, storage capacities, and basic software support for building repositories. So that's not the repository or set of repository itself, but infrastructure for you or your institutions to build topical repositories, for example, that will support research in your area. The platform is, as of now, based on systems like Invenio, DSpace, and ASEP. We are also experimenting with Islandora. It provides some core services like support for persistent identifiers, data storage wizard-like software for support of data management planning. We have some service desk and compliance and cybersecurity support, and training for technical aspects. Open Science 2 project call is focusing on domain-specific outputs. That means to use the foundation, the repository platform for building topical repositories. It started a few months ago, and it's working across topical clusters like biohealth, food, material sciences, social sciences, and there are also some cross groups like handling of sensitive data, support for artificial intelligence and machine learning, etc. By the way, there are open working groups. You can get member of this group and get information and also propose changes, services, what should be done in this area. Yeah, so if you are interested, you can you can be the member. And in a few months, Open Science 3 project call will be focusing on development of knowledge and skills. That means more or less providing support for people working with the repositories and supporting research in the particular area. It will be funded through so-called mini projects. And by the way, also in Open Science 2, there are so-called mini projects doing some particular small piece of work in the relevant area. So that's the infrastructure of the projects. And one thing or one activity is to provide you as researchers credit not only for publishing paper, but also for publishing good data set. Yeah, to have data sets to be first-class citizen. Good data set should be as good scientific result as good publication in a good journal. Yeah, that's another visualization of the activities. It's founded on a scientific community. By the way, the services of National Repository Platform, they were discussed in the open working groups I was mentioning before. So all the services were drafted by scientific community. Yeah, by the working groups, and the NRP is working on it, and EOSC CZ Secretariat, EOSC CZ Initiative is trying to coordinate it to be implemented in the projects. We also have a community of data stewards. This map can be found at eosc.cz website, and if you are data steward, you can register and can be found on the map. So part of the activities is interconnection of the community. There are the data stewards are quite active in Discord group that was set up for it as a communication platform with quick access, quick communication platform. We have a lot of research institutions and representatives, and this is the list of the working groups. Yeah, some are not obsolete, but were the most important when data repository platform was drafted. Others, the topical groups are now the main groups working in the particular areas, focusing on the creation and the use of the topical repositories. And again, you can be a member of the working group. The National Repository Platform is part of so-called national data infrastructure. You can see a lot of components are here. As I mentioned, National Repository Platform is providing the basic infrastructure, the storages, the basic software technologies that can be used to build topical repositories and other repositories, and interfaces are available to also connect with existing repositories that can be aggregated, and metadata should be aggregated in the National Metadata Directory. There should be National Repository Catalog to easily find the repository that's suitable for you. It's also connected with CARDS project, working on integration and upgrading infrastructure of libraries to aggregate with the data repositories and aggregate all printed and electronic documents across the country. And at the top level, central discovery portal should be available. So we are building infrastructure that should cover more or less all aspects here in Czech Republic, and of course it will be connected to European infrastructures. For example, metadata will be aggregated by OpenAirGraph and so connected to global infrastructures. Yeah. Now just a few slides about some concrete services. One of it is the Czech Catch-all repository that's available, and for pilot repositories, topical repositories are now under constructions. The molecular biophysics database is now in production mode. At the storage, the resources level, National Repository Platform should provide something like 50 plus petabytes of usable storage capacity. We of course have more raw capacity if there are backups and there are multiple copies of the data across the country, but storage capacities should be available. If we have some example, we are in fact supporting the FAIR data. Yeah, you can see support for use. There is a license. There is a persistent identifier. Also for authors is citable, and everything is made to be machine actionable in machine processable formats. Yeah, there are just some views on some particular things that are working, and we expect many more topical repositories available. Yeah, these are some particular services of the NRP. So we have safeguarding the access, authentication of authorization. As we have seen, the data can be safeguarded for access. We have sensitive cloud for processing of really sensitive data. We have services for connection of instruments directly to the repository platform to allow to upload data from the instruments, process them, and then store them. And we also have support for computational interconnection with computational capacities like Metacentrum for processing the data, getting them from the repository platform, and again uploading results. This is a screenshot from data management planning tool that's integrated, again, question actionable. We have persistent identifier support to be able to work with them. Licenses are important. We have a license chooser and support for working with licenses, and tools for working with formal descriptions of the metadata and updates of them, etc. So, and as we are running out of time almost, so I'm finished, and useful things are available. The slides will be available. The recording of this session will be available. If you have any questions, I will try to answer them. And if you get them later, there is email address, so you can write us and ask if you are interested. So thank you, and that's it from me.